The second part of our 2-1 notes for vertex form, we're going to cover how to write the equation of some type of quadratic when you're given information about it. Most of this is going to focus on writing in vertex form, but we are also going to look at switching it into that standard form, which we saw briefly on the second slide. So in this particular example, we want to know the equation of a quadratic function if we know it has a vertex of -2, 3, and some y-intercept of -1. Well, if you recall, a vertex is your hk value. So if I'm looking at an equation in vertex form, that's y equals a times x minus h squared plus k. To get the equation, I need to know numbers for a, for h, and for k. Well, I know my h is -2 and my k is going to be 3. The a is what's going to pose the problem there. However, because they tell you what the y-intercept is, remember that means you have an ordered pair that is 0, -1, I can use that information as my x and y to plug into the equation and solve then for a. So my vertex form equation, in order to get the value for a, is going to become -1 equals a times 0 minus -2, notice that becomes a +2, squared, and then +3. So we would simplify this. 0 plus 2 is 2, 2 squared is 4. We typically don't write things as a4. We would write this as 4a, although they do mean the same thing. And then carry down the +3. So to finish this out, we would subtract the 3 from both sides. We get -4 is equal to 4a. Divide by 4, and you get a is equal to -1. So since a is equal to -1, I can now plug in my a and my h and k into the vertex form equation to get my solution. So y equals negative, parenthesis, x plus 2 squared plus 3. And that would be the equation of the quadratic in vertex form. So again, just to review the process, you're going to plug in your h and k. You're going to plug in some example of your x and y. Sometimes they'll present it like they did here with a y-intercept. Sometimes they'll actually tell you what the ordered pair is. Plug everything in, solve for a. Once you get a, then plug in a and h and k to get the actual equation of the vertex. In vertex form. Okay, so now example 4. This is going through a specific example of a ball being thrown into the air. Anytime you throw something up in the air and it comes back down, that is going to be a quadratic model. We know that the graph is going to have a parabolic path, so it means it is going to have a parabola. We know our vertex is 120, so that means my h is 1, my k is 20, and the path of the ball includes the point 0,4. This would be my example x and y in order to find my a. But there's two things we have to do here. It says, what is the equation that defines this function? Write it in vertex form. That's like what we just did in example 3. And in the form y equals ax squared plus bx plus c. This is what we call standard form. So once we get our equation in vertex form, we're going to go back and rewrite it in standard form. And there's just some simple algebra steps we're going to do in order for that to happen. So first, I have my equation, y equals a times x minus h squared plus k. So I have 4 equals a times 0 minus 1 squared plus 20. Well, 0 minus 1 is -1. Squared is 1. So we have 4 equals 1a plus 20, which means a is -16. So in vertex form, my equation is y equals -16 times x minus 1 squared plus 20. Now comes standard form. For standard form, we are actually going to expand this x minus 1 set of parentheses. We're going to FOIL those, distribute the -16, and then combine with the 20. So standard form, I'm going to have negative 16, but I'm actually going to write the x minus 1s twice because I need to FOIL those. So when I multiply x minus 1 times x minus 1, x times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is another negative 1x. So my middle term is negative 2x. Then lastly, negative 1 times negative 1 is positive 1. Distribute your negative 16. Negative 16x plus 30x squared plus 32x minus 16 plus 20. Then I can combine the negative 16 and the 20. So I get y equals negative 16x squared plus 32x plus 4. And that is our equation in standard form. Standard form is nice because the number at the end is actually your y-intercept. So the one that's in the C position with no x, that is our y-intercept. And notice that matches what I have up here because it says it has to include the point 0, 4. Well, 4 is actually the y-intercept because x is equal to 0 in that point. So that's standard form. We are also going to be doing standard form in this next example because notice it says write the equation in Vertex form and in the form y equals ax squared plus bx plus c. So we have this parent function. It's the same parent function that we've always done. It says f is 1 unit left and 3 units up. So 1 left and 3 up of all the dots. Well, if it's 1 left and 3 up, that means my h is negative 1 and my k is 3. So for Vertex form, I'm going to have, let's see, I know that my h and k, h is negative 1, k is 3. I'm just going to pick some other point on the graph to be my x and y. So let's use the point 1, 7. Change it up a little bit. 1, 7, I can let that be my x and y. It just has to be on the new blue equation. So I have 7 equals a times 1 minus negative 1, so that'd be 1 plus 1 squared, and then plus 3. So 1 plus 1 is 2, squared is 4. So 7 equals 4a plus 3. 4 is 4a. That means a is 1. Our Vertex form is going to be x plus 1 squared plus 3. Because a is 1, I don't actually have to put that 1 on the outside, and that's actually going to make standard form a lot easier to complete. So for standard form, I have y equals x plus 1 times x plus 1, and then plus 3. So x times x is x squared, and notice I'm getting rid of the parentheses. Since my a was 1, I have nothing outside of it. I have x squared plus 1x plus 1x, so it's going to be plus 2x, and then 1 times 1 is 1. So x squared plus 2x plus 1. I still have that plus 3 in the end until I combine. So I have y equals x squared plus 2x plus 4. And that would be the equation of my new function. Notice 4 is actually the y-intercept of the blue g of x function, the one that I translated. So that's going to wrap us up for 2-1, Vertex form and quadratic functions. This standard form stuff, that's going to be the main focus of 2-2. So for this section, really all you have to do is be able to multiply to get rid of the parentheses from the Vertex form. Please make sure you are expanding properly. You do need to make sure anytime you have a set of parentheses squared, you write it twice. You got to go through that FOIL process. Go back and rewatch this video, rewatch the first video, and if you have any questions, please feel free to contact me.